So if I would have known that I had to give this talk, I'd print out a sheet and we could play buzzword bingo, because the idea of this talk was that at conferences you have a lot of talks and they try to sell you DDD in 30 minutes, and they try to tell you about event sourcing in 30 minutes, but they don't talk about us having to work with like legacy applications that are actually hard, where we can't just switch like this. So this talk is about how do we get something really old with no or bad architecture into a state where we can introduce some of the new exciting architectural patterns that we often hear about at conferences. So yeah, I skip all that part except for this one because that's pretty cool. At TNG we built cool robots. This one is the Avatar project, where we hooked up a robot to a HoloLens. So that's pretty awesome. Yeah, okay, so enough about that. Refactoring architecture is pretty hard, and this talk is not going to make it easy, but I'm just going to show a couple of techniques that have helped me. The response to this, at least for us in the JavaScript community, is often, okay, let's just rewrite. I think as we mature and as JavaScript applications tend to grow, that approach is not really going to work for us in the future anymore. Even for big companies, rewriting 1 million lines of code architecture application is just going to be too expensive and too time costly at some point. So when we imagine it, rewriting an application, we often imagine it something like this. We start, this is Dubai in 1990, 27 years ago, and then we build up this beautiful city where everything is new and fancy and everything just works. That's how we imagine it, but actually I felt this is sort of way more appropriate. Do you know which movie this is from? Yeah, yeah, exactly. So that's from Indiana Jones. I think we have to look at our legacy applications like this sort of storage hole with all these hidden secrets. So we don't start from scratch. We have this legacy application where there's so much domain knowledge hidden that is probably undocumented and probably no one even knows that it's there. So rewriting very often is not an option. We at TNG work for Vodafone, and actually one of the and by the way, like I cleared all this with the people, so everything I'm saying is cool. So yeah, so how we got to this project is because they hired someone else to do a rewrite. And Vodafone is not a small company. Back then it used to be Kabel Deutschland, so that's a subsection now. And as you can imagine, that rewrite of a huge company that does a lot of hardware things as well didn't turn out that well. So that's how we got into that. Now we're maintaining this legacy stack, and we've been maintaining it for years, and we're probably going to maintain it for years. But this is sort of some of the approaches that we have been using there. So yeah, that was pretty much the idea. We evaluated it, said, okay, the rewrite didn't work. They also knew it didn't work, but like for these things, you often need second opinions. Some of the problems they had, I'll skip over this quickly. Communication problems, there was lots of hidden logic. Of course, they didn't just rewrite it, they also outsourced the rewrite. So that's not the best idea. And then Big Bang integration, they delivered it at some point. Huge software stack, of course. Not microservices, lots of different services though, and Big Bang integration just doesn't work, and then that turned out to be a lot of money wasted. So we came in, we decided no, that's not the option, you need long-term support and you need to slowly work on this application. Okay, yeah, so the idea, like I never optimize the images for my talks because I'm running it on localhost, which I'm not doing right now. So what do we want? This is just something from Uncle Bob's definition of good architecture. It supports use cases and operations of the system, makes it maintainable, and supports the further developments of the system. All pretty obvious stuff. But I like this actually in his newer book and in his Lost Architecture talk, he's actually defining it in a different way. And I like this very much. He says that good architecture is, first of all, is not about methods or tools that you use. And good architecture also does not force you to make certain decisions. So if you start with a project from scratch and you're already deciding to use microservices, there's a good chance, unless you're Netflix, that you're doing it wrong. If you're interested in that, Google Architecture Lost Year, great talk by the infamous Uncle Bob. So one example that he gives, for instance, is this one. If you look at this blueprint, you could say that it's fairly detailed. You see all the different rooms and the compartments that the house is made up of. But you don't actually know what the house is being used for. This could be a storage house, this could be for offices, whatever, or even for a person living there. However, if you look at this architecture, each and every one, depending on the cultural context, of course, but you'll probably be able to tell that this is obviously a church. And this is sort of an example for what it means. A good architecture communicates what the system is about, not what technology stack you're using. Okay, so again, let's ignore this part. So this is sort of like how we often see a lot of applications. There's also a lot of, like, if you use Vue.js, for instance, you just have this given folder structure where you're supposed to put your views into a certain point and your service into another folder, and then you think you're doing a certain architecture, maybe you're doing MVC. But just putting stuff in a folder doesn't make it architecture. So again, you can ask yourself, what's the intent? You have all these folders given with certain names like controllers, whatever. This is an instance of a particularly terrible PHP framework where they have like helpers and libraries and third party and whatever those folders are supposed to hold. This is not architecture. So again, this one, good architecture is about intent and not about the methods or tools that you're using. So by looking at the folder structure, you should already be able to tell what the domain is about and not what technology you're using. Okay, yeah. So how do we find problems in our architecture? And this was sort of one of the main motivations of this talk. We can just spend hours and hours and hours just reading through our code, doing lots of analysis. But in languages such as PHP, JavaScript, we have to do that manually. There's not really much tool support for this. And that just doesn't work. So in the end, we need some tools. I created a tool for PHP. I'm planning on doing that for TypeScript, maybe even JavaScript. What it does pretty much is it analyzes your code base and tries to, first of all, visualize your code base on a high level, so you don't have to just click through everything, which is especially helpful if you have very large applications. And it also allows you to write assertions for your architecture. So right now, when we talk about architecture, is sort of this idea that we communicate from developer to developer, but we don't really put this into tests. Like, we don't really test that our templates don't actually call services directly. We don't make sure. We need tools for this in JavaScript. As of now, there is no such tool for proper architecture validation. That is because JavaScript has been terribly difficult to analyze. Since ES6, that's become better. When TypeScript, it's become a lot better. Okay, so how could this look like? That's actually not focused on PHP. So you pretty much run it on a code base. There's a lot of different things you can do. This is pretty much sort of a draft of what I want the other thing to be to look like as well. And you just get a map of all the different classes and what dependencies they have. More interesting is if you use that for to visualize the evolution of your application. So I ran this on the code base of my tool as well, which is fairly small. But if you just look at the packages and you do that while refactoring, you can see like slowly how your architecture is evolving. And I think that's a very powerful thing to have if we talk about architecture on a very high level. And in the end, nobody likes to use Microsoft Visio. Nobody likes to draw those things from hand. We should have tools for that, and we desperately need that in the JavaScript world as well. Here's another example. I don't have to show you. Actually, wait, you can. No, that's not good. That's not, did I put some in there? No, I'll have another example later. So, here, yeah. So, for JavaScript. Because like they just told me that, by the way, there's also JavaScript people, and then it ended up being like half the people in the room. But yeah, okay, so what you can do right now is you can just grep for require or import or use statements, and you can just put that through a tool like Dot or Graphics, and that can already create certain graphs of your application, which is a start. If you want to start just having you're hired by someone or you start with a new project, you have to figure out how everything works. That's something you can already do. You just grab through it, you put it in a tool that converts something into a graph, like dot or graphics, and it gives you sort of an idea of where the different layers in your architecture are located and if there are any layer violations. For assertions, you can do the same thing. So if you grab through every file and you see the use statements, that's an indication of what is being used in that file. Of course, that is not very clear. We don't really have proper naming in there. It's more on file paths, but still that can give you an indication. You can use grab statements to grab to make sure that certain files or certain files in a certain location cannot use or require something from a different folder, for instance. Like I said, it's still hacky. We need a tool for this. But yeah, that's something you can already do. Also, PMD also actually exists for JavaScript. If you're not using this, it helps you with some architectural issues as well. Also, use a proper IDE. We joked before about using Vim or Emacs, but none of us use Vim or Emacs for proper projects. We use a proper IDE for that. Now you have refactorings in VS Code that are very, very helpful if you want to start touching architecture. If you want to do larger refactorings, you definitely need tool support. Otherwise, you're just going to get yourself into trouble. And functional tests, in my experience, are very helpful. So a lot of us are working on new project, as is still the case in a lot of JavaScript projects. But if you work on an old project, you don't have any tests whatsoever, start with functional tests. Functional tests are a lot more resilient towards architectural changes. And the idea with architectural changes is still that, with architectural refactoring, is still that the functionality should not change. So it shouldn't break existing functionality. Functional tests tend to be more resilient, like I said. In PHP, that could be Behat. In JavaScript, we have Nightwatch.js, or now we have Puppeteer, which also works really well. And just try to cover the main use cases. And the good thing about architectural refactoring is if something goes wrong, you usually find out quite soon. Okay, so let's begin. Okay, shit, time. So I said like 5 steps, and I'm gonna leave out the last step. The first step I found to be the most important and the most painful one in legacy applications is knowledge extraction. In dynamic languages, what we often do, and this is PHP, but if I open the editor, we're gonna be here for a while. So I think if we think this is TypeScript, then it's almost the same. What we often have is we have these very useful type hints that something is a string. We don't really know what it is, but someone tells us that's a string. That string is supposed to hold an address, which doesn't actually tell us anything because an address can have a million different formats. So there's a lot of questions that pop up when we see this. There is no validation here. We don't know where it's being validated. In my experience, it's often validated all over the place in different places. There's changes being made to one spot, and then the changes are not being made to the other place. That's just not good. We can go one step further. We can say, okay, an address is probably not a single string. It's probably an array or whatever, or a map or dictionary of something. But that's still not much better. The next thing I often see in JavaScript that's just plain JSON objects pretty much is we just put that in an object, we name it properly, but we still don't really know what this is all about. We still have to figure out what the actual format of that is. So I think one of the most important things, now it gets a bit more difficult to read because of the whole PHP syntax thing, I'm a huge fan of immutable objects, immutable domain objects. So if you have something that is important to your domain, that is probably a product or a customer, you're going to have a lot of business restrictions that should be reflected in the code. And once you have a product in your code, you should know that this is an actual product, it's in a valid state, and it should not be floating around where you're unsure if this product is valid right now or not. If you enforce that when the object is created, it's actually valid and it cannot be created unless it's valid, then you get a lot of safety from that, because now you have a contract that you can pass out through your application. In TypeScript, for instance, all this garbage here would be gone. You don't need to write this or that. Actually, in TypeScript now, actually that's maybe even worth showing. Okay, let's see. Okay, wait, where are we? So TypeScript lang.org play. So you have a customer, and now you can do these. Where is this customer? Thank you. Too many languages in one day. What you can do is you can just define everything you need here. I think you can even put the read-only part here of type first name, for instance, whatever. You can just write it like this. I'm getting the syntax wrong now, but you don't have to worry about the getter stuff. You don't have to worry about exposing it to the public, and you can make sure that it's not writable as well. And like this, if you make very small objects that are all encapsulated, so every first name is a valid first name, every street is a valid street, and you once you have mapped your input to proper objects, you can pass them through your application, and you're safe from there. I said this is a very painful process because most of the time in the applications that I encountered, instead what we're doing is we're passing around lists or arrays or dictionaries that are not specified, that don't have an interface. What you can start doing in TypeScript or Flow, you can start defining interfaces for arrays. That's a good start. And then you will probably already figure out that a lot of your parts of your application are going to violate that interface. And you're probably going to find a lot of weird edge cases in your application. So I think getting there is actually the side effect. Getting the immutable domain objects is the side effect. The knowledge that you get through that is worth it. So that's the first win. Immutable domain objects answer a couple of questions. So for instance, if you take the address, is the address valid? Then it's always valid because if it exists, it's valid, right? So if we validate our, did I put it in there actually? No, I didn't put it in there. Okay. So you have to make sure that every object that you create, every value object is created only when it's in a valid state. If you have that knowledge and if it's immutable, that saves you a lot of pain and a lot of debugging. Now you don't have to worry about anymore if you can delete some property in a JavaScript object, because now your IDE will know this stuff. Your IDE can figure it out because it's properly typed and it can figure out the usages. Adding or removing properties is also not a problem because it will break stuff, especially when you're using constructors and the constructor expects a lot of arguments. If the argument is not there, it breaks. If you just have a JavaScript object and you leave one property out, no one cares. You're just going to be find out some way later down the road. So refactor towards objects and proper objects, not just loosely typed JSON objects. What if a value changes? Well, it can't. It's an immutable domain object. You have to map it if you want, and you have to create a new object. Here's an example. Again, sorry for the PHP. What we want to do here, this is for an imaginary world where, so for instance, Dresden would not be included here because Dresden has weird zip codes, in case you didn't know. So yeah, this is one of the examples. So once you create this, you know you have a proper zip code, you can pass it around, and you never have to worry about that again. If the validation logic is more complex, so for instance, for a user, you probably have to validate. If there are other users, then you have to extract the validation. You can't do it in that one anymore. Then you have to use something like architecture validation to make sure that no one else creates that object. Okay, so immutable domain objects are not technically an architectural refactoring, but I think they're very important. You can start talking about architectural interfaces if there are no clear interfaces. If you're passing around products that sometimes have an article ID, sometimes have an ID, and sometimes have an article number, it's just going to create a mess. Looks easy at first, but this is a very, very painful process and an ongoing process, and you're going to find a lot of inconsistencies along the way. So the knowledge you gain from this is who talks to whom and about what. So there's JavaScript stuff, PHP stuff. Inversion of control. This is really important. If you're not doing proper dependency injection, you're going to run into problems as well. Let's go over this a little bit quicker. So always use constructor dependency injections. Some frameworks use setter dependency injection. but that allows everyone to change your dependencies at any point in time, which is something we don't want. If we depend on a database, we don't want someone to change the database while we're doing stuff. There's a lot of frameworks where they just inject the dependency container itself. I'm sorry I don't have time to talk about this topic more, but those are two really important things. Domain objects themselves, I like this term.
If you get into recursive stuff, if you have dependencies inside of an object, how do you do it then if you don't inject the container itself?
You mean cyclic dependency?
No, just nesting. Just an object that has dependencies, and inside it uses another object.
Right. So the idea is that if you do it all properly, you're pretty much gonna bootstrap into this like graph that just goes bigger and bigger the further down you go. So you start at one point, you bootstrap the project, so you bootstrap the application, so you start in a controller, which depends on the next layer, which has these dependencies on the bottom layer as well. So by doing that, you can pretty much just imagine a tree. You start at the very top, and obviously you shouldn't go down 10 levels, but you just pass it down through like 3 or 4 levels to your service container, and that's pretty much where it should end.
Usually when you instantiate a class and given an object that needs dependencies to be created, this object is already created with the dependency injection container.
Right.
So you already when you start initializing.
Right. Thanks for clarifying that. So that's what I mean by domain objects are nobles. You don't have to worry about injecting something like zip code. Right, that's something you can happily use new. You also don't have to mock this in your test. That's fine. These are stupid objects. Everything else should be injected. You can do one big container if you're using a small application. You probably have to split this up if you use a bigger one. You probably have to have factories within the container. That's also perfectly valid. So a factory which decides which service has to be instantiated depending on which. So for instance, if sometimes you can only take a certain decision, like which objects needs to be created at runtime, you need to delay this decision to something, and that's why we have the factory pattern. So we inject the factory, and at runtime the factory will decide for us which object we need. So for instance, which service endpoint we're hitting. So yeah, factories are fine. I left my drink somewhere. 2 talks is too much. Yeah, so there's lots of stuff, so ignore this. For JavaScript, there's lots of alternatives. Okay, common problems. So oftentimes you will see something like this, and there are side effects in a constructor. This is obviously something you want to avoid. You can do that by either using lazy instantiation. You can encapsulate this in a factory, pass down the factory, and when you actually need it, you get it out of the factory. Option 2 is you extract a side effect, so you remove the init statement and you call it where you actually need it. However, this creates something called temporal coupling, which has the problem that you always need to remember to do this, and you're probably someone is gonna forget it, and then everyone's sad. Static usage is something that you often encounter, less so actually in JavaScript applications, but in PHP applications you tend to see this a lot. You can just wrap this. I think the sort of functional background of JavaScript has helped against that, in my opinion. So what I did in that case is you just create a wrapper object, which pretty much just wraps the static calls. That's the first step. Later you can refactor this, but now you can properly inject this and test this. Okay, I think that's too PHP specific. Step 3 is you have to show the intent. Be explicit and move away from the old school MVC folder structure. I think actually JavaScript has pretty much obviously moved on from that, and they're creating smaller applications with that are more focused on the domain. But still, if you find yourself in this situation where your objects, you just put, I'm not sure if I have an example here. No, I do not. So imagine you have a service folder and you just put all types of services in there. that's pretty much going to make it hard for you to actually reason about your application, because those services are not standalone. They're probably communicating to other things. And we call that cohesion. So cohesion means measures pretty much how two modules fit together, and stuff that fits together should be closely located together. So ideally, if you're using your IDE, you're writing code, then that code, the code that you're working on right now, should be visible on the left pane in the IDE. That's a pretty good indicator. If instead you have this like services folder open and there's like 30 services in there, you're working on one of them, the other 29 you don't care about, but all the other objects you're communicating right now in that class are somewhere completely different. If we have this, it's probably going to be difficult for us to split this up later. And that's where I'm trying to go with this. There's a lot more to that. Okay, step 4, and I like this. This again, a quote from Uncle Bob. Abstract away the delivery mechanism. Very often when we develop an application thinking like, okay, we're going to develop a web application, which already locks us into a certain mindset. So we're already thinking, okay, which framework do we choose? Do we do this with Vue.js or do we do it with React? When that's actually not something we should worry about in the beginning. If we start from scratch, which is not what we're talking about here, then an architecture should allow us to not think about that. We should first write down what we actually are trying to do for our customer and later patch on React or Angular or whatever, but it should not be tied to that. Right now we're at a point where if we want to switch JavaScript frameworks, it's a rewrite. And this is part of the result of that. So what Uncle Bob said is the web is just a delivery mechanism. So if you're writing your application, you should not have to think if this is going to be on the web later, or if this is going to be a native app later on, or just a console application. Your domain should be completely separate from actually knowing if this is going to be a REST service or if you're going to use GraphQL. Oh, so yeah, okay, I've already spread ahead. Active record is something that we also use in the JavaScript world, which is pretty much objects which know how to fetch themselves from the database, know how to save themselves to the database. I'm not a huge fan of them because they break the single responsibility principle. You're doing too much with that object. I prefer to hide them behind repositories and pass out very stupid objects that actually don't do much. They just encapsulate the domain. Another good question is if your controllers know what happens to the data. If you can look at your controller and you figure out which endpoint your data is going to land in, you're probably tied to that too much already. That's pretty much the same thing. Another buzzwordy thing, how expensive would it be to implement event sourcing? Again, event sourcing is just a storage mechanism that should not be reflected in your controllers, for instance. Okay, buzz. Yeah, a good question is like, could you move your core code out of your web repository, or would that break everything? In most cases, I think the answer would be no. But that's where our refactoring should take us. That we have this little thing where we call our domain logic, where we just talk about the problems we're trying to solve at the end of the day, and then this other part of our application which deals with where do we save this stuff? Do we have a database, or do we just fire this off to another service? And how do we bring this outside? Do we actually render templates, or is there a web service? Okay, so let the fun begin. This is where the buzzwords start. So if you've done all that, all these fancy things we hear about, microservices, if we did this properly, if we have our components separated by our domain and not actually by the technology, it doesn't really matter to us if we have them if we communicate over an interface or if we communicate over REST. But the very first step we need to do is to separate the different domains of our application. So interface is an abstract term. Interface can be something like a interface in TypeScript, but interface can also be something like HTTP, and obviously it's more difficult to connect over HTTP, so do that as late as possible. But in the end, we just have to start thinking interfaces between the different domains of our application. An example for that would be, for instance, maybe we can completely take out the whole basket of our e-commerce platform, and we can treat that as a completely separate application, which we can later, if we have too much load, run as a separate service. But we can't do that if we tie everything together and if we just separate everything by technological aspect. Okay, so yeah. Here's a good example. I tried this thing, this agile thing, where I draw everything myself, and then that turned out terrible and took me a lot longer than just using it, using a computer. So let's say we have something like this. So we have a component, we have some sort of interface that we expose to the outside. Here is not plain PLP, but JavaScript, and then we communicate with each other. And we have, like the thing I spoke about in the beginning, we have something that validates, some tests that validate that nothing is communicating from back here to back there. We have a clear interface. Then switching to this, to something where we call this service instead of component, and we use something like REST. Suddenly it's not a big step anymore. I'm making it sound easy, but I'm just trying to communicate the way to get there. There's this thing called the fallacies of distributed computing. I'm not going to talk about it because I don't have time, but Google it. If you're into microservices, that's something you should definitely know about. There's a lot of assumptions we make about the network which make microservices different. Domain-driven design, if you've listened and if you've heard something about domain-driven design, this is pretty much the whole thing I've been talking about. We have to map our domain first and our technology second. If you've done that, then by now we already have that. We can check off another buzzword. The last one, I'm going to spare you this because it's really late now, and that's probably another step that we could take to actually go for event sourcing, but that's actually kind of decoupled from the rest. So, summary. Architecture refactorings are costly and risky. That's something you have to be aware of. You probably can't refactor a big application in a few weeks. That's an ongoing project. And you have to make sure your goals are measurable. So even if there's no tool right now, write some scripts that grab your application and make sure, if you say that, okay, we want to have this architecture, write a couple of scripts that make sure that you're at least not requiring things that you shouldn't be requiring. So that's, yeah, define and test your architectural constraints. Again, the steps that I like, I just named them myself. I think the first step should always be knowledge extraction. If we're passing around loose interfaces such as simple JSON objects, you should probably wrap those in safely typed objects first. Inject your dependencies so that everything is unit testable, and then abstract away all the technological stuff. And show the intent. That should already happen in the knowledge extraction, but make sure that your application communicates what your business is about. So that is it. Reading recommendations, ignore the first one. All the other 4 ones are actually great reads that I can recommend. Especially Clean Architecture. It's a very light introduction to architecture that came out just recently. Thank you. Sorry for rushing through this. Hope it was not too bad. Thank you.